And now we are recording. Okay, so what we're talking about today, guys, is just we're continuing with the substitution idea. And so what I'm going to do is take you through an example like the stuff that we did last week. And that's sort of our process one. We have a second process we're going to learn today as well that is the same idea happens. So I don't want you to think that what we're doing is actually different. It's just that where we have to put things is a little different, and that's kind of why I want to talk about it. So our first thing that we did, we had a system of equations, and I'll start with this. So we would start with a system of equations, which is just two equations. So y equals 4x minus 6, and y is equal to 2x plus 10. So two different equations. And what we're trying to find is a solution x and y that works for both of them at the same time. Now, we talk about substitution. What we're trying to do is to recognize that since both of these are y values, we can say, well, if these are both the y's, then I can take what this y is equal to on this side, and I can just replace it over here. So I can rewrite this equation. And instead of that y, I can write the 4x minus 6. And then everything else is still over here that it's equal to the 2x plus 10. And now I can just take this equation and solve it for x, and I've got half of my answer already done. Now, that is the substitution that we do. We substitute this expression in for the y, we rewrite it, and then we're going to solve this equation. Now, this is where you got to tell me if you remember what we did. Do you guys remember this, where we'd have two equations like this and we replace this other one over here? If you remember this, say yes. If you do not remember this, say no. I got one yes. And if you don't remember it, it's okay. Will you combine like terms? Yes, I will combine like terms in a minute, but we have to remember is that when we are solving a system of equations, or when we're solving an equation that has x's on both sides, I look on the same side to see if I can combine terms. So this is x and 6. I can't put those together. 2x and 10, I can't put those together. So what I'm going to do now is take the x's that I have here and move them to the same side of the equation, and then move the numbers to the other side of the equation. Do you guys remember which x I get rid of first in this case? What x am I going to try to cancel out? The smallest one, absolutely right. You look at the two numbers in front and you say, I want to get rid of the one that has the smallest number in front. So I got a 4 and I got a 2. This 2 is the one I'm going to cancel out, because if I cancel the smaller one, I'm going to have positive numbers to deal with, which is always easier. So if I cancel out this 2x, the way you can cancel it out is just by subtracting it away. I got a positive 2x. If I do a negative 2x, this will go away. But I have to do the same thing on both sides of the equation. So the question that you asked Janae about combining like terms, we will, but it's kind of like you have to do the opposite here to make it a zero pair first. And then when you bring it to the other side, that's where you're combining your like terms, okay? So here, this positive 2x, negative 2x, zero pair, gone. Now I'm going to rewrite this and combine these. So 4x minus 2x is going to give me 2x. That negative 6 I didn't touch, so it stays the same. And that's going to equal, since this is gone, just that 10. Now, what am I going to have to do to get this to the point where I can solve the x? There's another step I've got to do here. Do you guys recall now what my next move is? I got to do a plus 6. That's absolutely right. Because now that I have all the x's on one side of the equation, I want to get the numbers on the other side. So I'm going to take that minus 6, do a plus 6, so that I can make a zero pair here and it goes away. I got to do the same thing on this side of the equation. So here's my zero pair gone. I am left with a 2x. And it's going to equal, again, I'm combining the like terms here. 10 plus 6 is going to give me 16. One step away, guys. What is my last thing to do here to solve just for the x? What do I do to both sides of this equation? Oh, somebody's going to tell me. How do I get rid of that 2? Divide. That's absolutely right. If you've got a number in front of your x and you want to just get rid of that, you divide by that coefficient, because it cancels it out to a 1. And I will have 1x is equal to 16 divided by 2, which is 8. Okay, so we are halfway to our solution now. We know remember, we're solving a system of equations. We have an x value. You guys can't see that. We have an x value and a y value. We've just got the x value as an 8. Still got to find that y value to get the final answer here. So what I need to do is look back up here, pick one of these two equations, plug in that 8, and then we'll see what we can get. Bottom equation sounds great. Again, it doesn't matter which one. You just pick one and solve it. Here, y equals 2. Now I'm going to put parentheses for x, plus 10, because I am going to plug the 8 in for that x right here. So this 8 is going to go right there. And now I can solve. Okay, so here we go. Y equals 2 times 8 plus 10. 2 times 8 is 16 plus 10, which means the y is equal to 26. And that's going to be my answer here. So our solution to this final system of equations is 8, 26. X is 8, y is 26. Now, do you guys remember this now? I mean, we had 2 days of class and then a 4-day weekend before we got to here, and 80,000 pounds of snow. So is this ringing bells? You guys feeling like I kind of remember this now? Wow, that's great. I like the yes. I appreciate that you guys are there. I'm going to do another one like this, and then I'm going to show you how the second process works. It's not difficult, but it does involve thinking a little bit differently about what it means to substitute, because these have been awesome because it's easy to kind of set these equations up and solve them. The other one is a little bit harder, and that's why I want to introduce you the concept, but it's not something that I'm going to make you do a bunch of. There certainly isn't going to be one of these on the quiz. I just want to make sure that you kind of have your head wrapped around it, okay? So with that being said, let's take a look then at another example like that process we just did. So I'm going to, here, let's do this one. Y equals 8x minus 3, and y equals 5x plus 9. All right, guys, what is my first step? Who remembers? What do you guys think? By the way, I do want to applaud you guys for being as interactive as you have generally been here. Do you guys remember my first step? Haha, I spoke too soon. Yeah, Jemiah, thank you. So I take, since they both equal y, I take what the y is equal to, and I substitute it in for that y. So I'm going to do 8x plus 3, 8x minus 3 instead of the y, because I'm substituting them both in. And I'm going to keep everything else the same. That is going to equal, it's actually 5x plus 9, but I got you. Wrong 10. Here we go. Equals 5x plus 9. And again, guys, no, it's totally fine. Honestly, I always said plus 3. I could have made a huge mistake as we do this as well. Okay, so what I want to make sure we can see here, the process is almost always the same. You substitute in for the value that you have, then you're solving for the x. Once you get the x, you plug it back in to find the y. So when we're doing this, we've got to try to get that x by itself. Which x am I canceling out, 8x or 5x? Which one? I cancel the 5x because it's smaller. Minus 5x, minus 5x. This side becomes a 0 pair. On this left side, I'm combining like terms. 8x minus 5x is 3x. That minus 3 didn't get touched, so it's here. We're going to put that 9 right down here because the x's are gone. Now I got to put all of the numbers on one side. So how do I cancel out that negative 3 to make it go over here? I'm going to do a plus. It's got to be that exact same number to cancel it out. Negative 3 and a positive 3 will cancel out as a 0 pair. I'll do my plus 3 here, which is going to give me that 3x from this side is equal to 9 plus 3 or 12 from this side. Now, what do I do to solve for that illustrious x? I got to divide by that number in front. Divide that by a 3. These will cancel out and give me a positive x. 12 divided by 3 is going to give me 4. So again, I'm halfway to my solution. I know that my x value is 4. I do not have my y value yet. So now I pick one of the equations here and I plug it back in. I'm going to pick the bottom one because why not? Y equals 5x plus 9. And so I'm going to put that 4 in there for the x. And now it's just time to evaluate. There are a lot of steps. I do appreciate that. Somebody said this privately. This is the same process as what we're going through, though. And so while I realize there's a lot of steps, it's one of those things where because it's the same, we want you to get more and more familiar with it so you feel less uncomfortable. 5 times 4 is 20 plus 9, and 20 plus 9 is 29. So that's going to be my y value right there. Now, it goes quickly. And I guess that's the part about this that I want to make sure that you guys sort of have in your head. This is a lot of steps. And what I want you to make sure that we can do right now is this. I want you guys to sort of take a place here that in your head you're thinking, okay, do I feel pretty comfortable with this process? Because these processes are great since they're both equal to y. You move this over here and you solve it. And that's great. And that's kind of something that I would really love for you guys to feel secure in your knowledge of how to do this. Because what I'm going to do right now is I'm going to make it a little bit more complicated. The process is similar and it's the same general concept, but it's going to look a little bit more complicated. And because of that, I don't want you to do that thing where students tend to freak out when you make a change. We're going to go through some examples. And again, I'm not going to test you on this second process, but at least not for a while. But I want to make sure that if we can get this one secure, we're good. This next one's going to make you feel a little bit more uncomfortable, but it's going to be something we're going to support. So I just want to make sure you're in a place for that. Because we got about 14 minutes left, which should be plenty to do about 2 examples and answer some questions. And that's sort of what I want to be able to do. That doesn't mean these are going to take like 7 minutes at a time, but I do want to make sure that you get a chance to see them. Now, I'm going to write this system first. And then I want you to look at it and go, okay, I think I know what's happening. So, and if you don't, that's okay. So here are our 2 equations. Y equals x plus 3. And the second equation is going to be 3x plus y is equal to 7. All right, guys. Why is this different than what we did before? Oh, somebody's got to tell me what makes this setup different than before. Yeah, it's a different order. And look at that second equation. That second equation right there is not y equals something. So I can't just take the left side of the equation and rewrite it because there's more crap over there with the y. And that's the part about this that I want to make sure you see how we do it. It is exactly the same idea, okay? So I don't want you to think that you're doing anything crazy, but this is what you have to do with a problem like this. We know that we have y equals something here. That same y is right here in the equation. Just like I did before, I'm going to have to substitute. But when I substitute, I'm going to be taking that expression and replacing it inside of the equation. It's not like I'm replacing the whole left-hand side of the equation like I did before. I can't forget to keep that there and to keep this plus here, but I'm replacing the y with this whole thing. So when I do this, I'm going to have to say, okay, well, I got 3x plus, I'll leave a little bit of space, and it's going to equal to 7. When I replace that y with the x plus 3, I got to write the whole thing here. Now, it doesn't change it much, but because I'm replacing the y with a whole expression, sometimes I'll put parentheses around it to make sure if there's anything in the outside, I've got to keep that in place here. Here, I'm just adding it, so not having anything around it is okay. That's how I replace the y with the expression inside of it as opposed to the on the other side. Now, I don't have anything too difficult to deal with. I've done the substitution. I still have to solve this for x. It's just that I don't have my x on the other side of the equation anymore. Now everything is on one side. So I can just combine like terms right here. That and that are like terms. And they're on the same side of the equation. So I don't have to do any opposites or anything to put them together. I just put them together. I've got 3x here. I've got another x here next to it. So total, when I put them together, it's going to give me 4x. That plus 3 I haven't done anything with yet, so that's going to be right there. That 7 comes down here. Now I have an equation to solve. 4x plus 3 equals 7. Again, it looks different, but now that I'm here, it looks exactly the same as what I've been doing before. I've got to get rid of that 3, so I can subtract 3 from both sides, just like I had to do before. And now I get my 0 pair on this side, and I'm going to get the 4x is equal to 7 minus 3, or 4. And I had to divide last time, just like I have to divide this time. Divide by 4, divide by 4. I'm going to get that x is equal to 1. It looks a little different to get there, but the process is the same. Replace the y in the other equation, solve that equation for x and get it. Now we're halfway to the answer. We just got to find that y value to get to what we're going to do. This is the place where what you do here isn't different, but it just means you've got a little less choice. I can plug that 1 into either equation to solve it. I can go up here, I can replace x with 1 there, or I can replace x with 1 here. I would always suggest taking the equation that has y equals and using that one as our rewrite. Because when I do this, it's always easier to do the work on the right-hand side than it is to have to mess around with it over here. So this, I've already got it solved. I've just got to take that 1, plug it in here for where the x was. And now, guys, I bet you could tell me what's 1 plus 3. If I put those together, what's 1 plus 3 going to be? Yeah, it's just 4, guys. My answer to this is 1 comma 4. Now, I'm guessing that you might have some questions about this. So let me just zoom out a little bit so you guys can see all of it at the same time. Is there anything about any of this here that stands out as a place where you're like, I really don't understand where you got that? Or what did you do when you subtracted 3? Why did that happen? Or when you divided by 4? Is there anything here that stands out as I really don't get where that step came from? Now I'm going to do another example and show this to you. And then we're going to keep doing this like for the next couple, like you're going to have plenty of practice, but is there anything that stands out right now where you're like, I don't know where you got that. What did you do with this? Okay. Well, here's what I'm going to do. So really quickly, I'm going to take what we have here and I'm going to write another equation. But just remember, our first step was to substitute, then rewrite it. Now we have an equation in terms of x's. We solve for that x by combining like terms. Then once we've done that, we solve for the x and we plug it back in. That process is the same no matter what, okay? So I'm going to write one that is a little bit more difficult, but not a lot more difficult, okay? And I think this will probably be my last example of the day because I don't want you to get to a point where you get overwhelmed, and we'll do more of these later. Our equations will be y is equal to 2x minus 1, and then I'm going to have x plus 2y is equal to 8. Okay. Do you recall what I did first on that last one? Anybody remember? Replace the y with the equation. You're absolutely right. Now, I tend to go in here and circle them both so I see where it is. So I'm going to put this in here. Now, I want to point something out, guys. This y has a number in front of it. It's called a coefficient. Anytime you have anything with the y or with the thing you're substituting in, you've got to use parentheses. And here's the reason why. Everything else here, x plus 2 equals 8. Everything else here has to stay the same, including 2 times whatever that y is. because I'm replacing the y with more than one thing in this equation here, I need to make sure that both things are getting multiplied by that 2. So when I rewrite it, I've got to use parentheses to make that work. So inside here now, I'm going to have 2x minus 1 because I've replaced that y with the whole thing. Now, your first step here, it's very similar to what we did the last time. But because you've got a set of parentheses, what I'm going to want you to do here is to distribute. Because if I distribute that 2 to both things, now I can just put everything together. So when I rewrite this, that x didn't get touched. I'm going to multiply that 2 in. So 2 times 2x is going to be 4x. 2 times negative 1 is going to be negative 2. And that 8 is still over there on that side. So I distributed first. Now, just like I did before, they're on the same side. So I'm going to combine like terms. X plus 4x is going to give me 5x. Minus 2 is equal to 8. And now I just go through the process the way that I did before. We've got to do the same thing on both sides. So I'm going to add 2 because I've got to cancel this one out over here. And now I'm going to get that 5x on the left is equal to 10 on the right. And now to get rid of that 5, I'm going to divide it. And I'm going to get that x is equal to 10 divided by 5 is 2. You guys can almost see all of that. Okay. So as it stands, I've got the first part of the answer. Just got to get that second part. And so I'm going to use that top equation. I'm going to rewrite it. Y equals 2 parentheses for x, just like we had to do up here. It's just we're now substituting in for the value itself. Throw this number right in there. And it's time to solve. Y is equal to 2 times 2 is 4, and 4 minus 1 will give us that y is equal to 3. All right, guys. That is a whole lot of problem right there. But you got through seeing all of it. Does anybody have anything that happened here that you're like, what the hell is this? See, I said hell. It got recorded. It's on the thing. So there we go. So got the first part, the plugging it in. The second part in terms of solving it, is that a little bit off? So we still got about 4 minutes left in class, and I can go through another one like this one, but I also want you to recognize you're not going to do this a bunch. So I wanted you to see it, the when getting y part. So when you get the y, all you got to remember is just make sure you're plugging it into that top equation, right? And the reason I say that is because this second equation, it's just not written in a way that's going to be easy for us to plug that number in and solve it. If I use that top equation, we should be good. Okay, let me do this. I want to show you really quickly what your assignment is going to look like on Delta Math, so you see what you've got to do. I want to see how this is going to go. Give me a minute. Okay, so when you get this to Delta Math, let me move some stuff out the way. Okay, so we're going to do this. Should be up on here. Just want you to see. Perhaps it'll let me log in quickly because my internet's not crappy. Or perhaps it won't because, you know, things don't work super well. Okay, so what I have here, you're going to have this part right here. It's the 6th week 7 Graphing and Systems 215. That's going to be up there. All you got to do, your level 1 substitutions, you got 4 of these. These are just going to be straight up take, rewrite, solve, okay, and submit the answer. And we've already done some like this. The only other thing you're going to see, you got one of these problems. This is that situation where you've got to replace the y with what we have here. So just remember, if you're going to do this and you've only got one, so if you only do the other one and you can't get this one problem done, you're still going to get full credit. I just want you to kind of see how this is going to work. If I'm going to go in here and retype it, I can take this equation here. It's going to be 2x plus 3, and then I have parentheses, and I'm going to take that x plus 9 and put it right in here for where the y is. And that's going to be equal to 32. And now I can go through this, distribute, and solve. And that's the way that this would work, okay? I think that's probably enough for right now. Let's see if this even shows up. We got about 1 minute left, which is fine. Okay, so let me do this. Let me stop recording.